Hi folks, I wanted to give you a quick demo on using batteries and Bluetooth with your Circuit Playground Blue Fruits. One of the nice things about the Circuit Playground generally is that it is well equipped to work with a battery, so you can do some remote or untethered applications. But even better, the Circuit Playground Blue Fruit can communicate with a computer or a mobile device through the Bluetooth protocol, and with the battery then it means you can make a completely wireless device like a game controller. So let's look at a few things you would need to do if you want to pursue this option. So just looking at the Blue Fruit device, we are most familiar with powering it through the USB port, which works fine. It can also take power though from a battery that you connect to this battery jack here. This uses a special kind of connector called a JST connector, so you want to make sure that you get a battery or battery pack that's compatible with that connection type. Now, just to make sure we're clear, if I go to the guided tour here and look at power and data, the USB connector should receive USB power, right? So USB power is 5 volts. You don't ever want to put anything that's not 5 volts into the USB jack. So one way to do a cordless operation is if you have a like backup battery pack to charge your phone, for instance, that has a normal USB port on it that you plug your phone into, you could use that to power your Circuit Playground. That works fine. Just use a micro USB cable. The other option is to use a battery pack made specifically for small electronics. The advantage here is that sometimes you can get a smaller battery. So for that, you use a JST connector. You can give the board through this jack up to 6 volts DC input, okay? And depending on your battery configuration, well, that will depend on how much volts it outputs. So for instance, you could connect a 3 AAA battery pack. If those are in series, I think each AAA is like 1.5 volts, so you'd be giving 4.5 volts ish to the connector, and it will scale that down to the 3.3 that it needs to run the board. Okay. You can also use lithium polymer batteries, LiPo batteries. Those are even smaller. The one thing this board does not have though is an onboard lithium polymer battery charger. A lot of the other Adafruit boards do. They're made to specifically work with LiPoly batteries. This one does not, so that you can use the AAA batteries, which may be NIMH rechargeable. They might be alkaline and non-rechargeable. If you connected either of those to a circuit with a LiPoly charger on it, they could catch fire. So she avoids that and goes for like a wider variety of batteries that work with this board by not including the charger. So to look at specifically some of these chargers, right, here's a 3 AAA battery pack. It's $2. You can see the batteries go inside, and it connects with this little white plug. The battery packs have a red and black wire on them for the positive and negative. It's important that you put the positive and negative in the jack the appropriate way. The nice thing about these jacks is that you can't plug them in backwards, right? So as long as it's wired correctly from the pack or the battery, it will go in correctly to the board. This is an example of lithium polymer battery. These come in a variety of sizes and capacities. So this one is a 500 milliamp hour battery at 3.7 volts. 3.7 is like the perfect voltage to run 3.3 volt devices, it only has to step down a little bit of that extra voltage, and it ensures that the battery is always giving out enough voltage to run the device without overvolting it. If we look down to the technical details, it will tell us the size of the battery that can be useful. This is 1.1 by 1.4 inches, and it's less than 1/4 of an inch thick. So that would easily fit underneath or behind the circuit playground, right? Like, depending on how you want to configure this, you want to make sure that, the battery's the right size for the design of the enclosure you're making. These are a little bit more expensive, but I mean, with this one you would have to get the batteries too. Then in terms of the milliamp hours, that's like a new unit for us. Milliamps we're familiar with as a measure of current, and the hours sort of tells us how long it can provide that current for. So a 500 milliamp hour battery can provide 500 milliamps of current at 3.7 volts for 1 hour. Another way to think about that is it could provide 50 milliamps for 10 hours. Or it could provide 100 milliamps for 5 hours, right? So as long as the hours times the milliamps equal the total milliamp hours, you're good. In terms of like how much power does a circuit playground use, it doesn't say in the guide anywhere how much power it uses, because it's going to really depend on how much stuff you're running, right? How many sensors you're using. Are you using the NeoPixels or not? Do you have other LEDs connected or not? Every little thing that you do on this will use some amount of power. So doing more stuff will use more power, doing less stuff will use less power. But there's no, like, the circuit playground uses X amount of power. It really depends on your code. If we recall, each of the pins, right, I think can output as digital out like 40 milliamps, maybe 50 milliamps of current, right? So if we had all of those going, there's easily a couple hundred milliamps of power right there. So I think the 500 milliamp hour battery is like the smallest one that I would use for the circuit playground, and you can certainly get bigger and smaller ones. Here's a 1200 milliamp hour battery pack. You can get a really large 2200 milliamp hour battery pack, etc. There's a whole variety of shapes and sizes and capacities of the batteries. Now, as I mentioned, this battery is a little trickier to recharge because the board will not recharge it. So if you want to use a tiny lithium polymer battery, I recommend this tiny lithium polymer battery charger that just uses USB power. You plug the battery in and it will recharge, and it has all the circuitry here to stop charging it when the battery is full so it doesn't overcharge. You do want to be careful when working with the lithium polymer batteries if these batteries are designed to be like embedded in something else, right? They do not have as sturdy a outer casing as the like AAA batteries. Now, they're perfectly safe to use, but you don't want to bend them, you don't want to crush them. If you notice them swelling or anything like that, or tears in the packaging, you want to get safely get rid of them, because lithium polymer is the kind of battery that can explode if it's not treated or taken care of well, right? A few years ago there was a big problem with Samsung phones doing this, right? And it was because of the lithium batteries in there. So just be careful with the batteries and you should be fine. Okay, so that's the first step, right, to getting our wireless going, is to have a battery pack instead of the cord. Now, if we want to communicate with the computer, right, we're making a game controller, we want to send information back to the computer, we can't use the USB port we need to use Bluefruit, or Bluetooth. So let's look at how we can do that with some Arduino code. Now, most of this I am drawing from some examples that actually come with the when you install the Circuit Playground Bluefruit with the board manager. It comes with some examples, so I'll show you where those are. If you go to File, Examples, Adafruit, Bluefruit, NRF52 libraries, peripheral, then we've got the blue fruit ones here, right? So the Bluefruit uses BLE, I think it's Gen 5 Bluetooth. And so I was looking at the keyboard example and the mouse example to build this demo I'm going to show you now. So if you want to go into more depth on any one of these, you can look at these examples. Here, there's even a gamepad example, right? If you want to make a specific game controller emulator instead of a keyboard or mouse emulator. Plus, several other examples of how to use the Bluetooth. Bluetooth requires a little bit more setup than we're used to, so I'll walk through some of that. And again, a lot of this I'm just taking from the examples. So I do not know exactly how Bluetooth protocol works. I just trust that the library is written well, and if I use the library, it will work. Okay, so I'm going to include the Bluefruit library. I need to make two objects specific to that library. One is a BLE dis, and then a BLE HID Adafruit object. I'm calling that BLE dis and BLE HID. The DIS is for Device Information Service. That has to do with like how the Bluetooth device broadcasts itself to other devices, so they can learn how to pair with it. The BLE HID has to do with setting up the device to emulate an HID, which is a human interface or a human interaction device, like a keyboard or mouse or gamepad. So you'll see this HID protocol is very common in USB devices, and so they've replicated that for Bluetooth here too. And then the only global variable I have is a debounce. Dear Lord, how about that? That's better. Debounce of 100 milliseconds. In my setup is where I'm going to turn on a lot of the Bluefruit library stuff. So all of these Bluefruit commands are library commands. I'm turning on the library. I'm setting the transmit power to 4. Then I'm going to initialize my BLE-DIS device. I'm going to set the manufacturer to be Adafruit Industries, the model to be a Bluefruit Feather 52, and then I'm going to turn that on. I'm going to start my BLE-HID object, and then I'm going to start listening or start advertising the device function. So this is a function that I wrote. I didn't actually write it. I copied it from the examples. It's down here at the bottom. And so this is going to do a lot of that stuff. Like, it's going to build the advertising packet. So for instance, when you go to your computer Bluetooth settings, does the device appear, right? We're going to add the HID service to it, the name, and then we have some other stuff down here, some settings, like if the Bluetooth connection gets disconnected, restart. What's the interval for trying to advertise? Does it have a timeout, etc.? So that, again, I didn't mess with any of that. I'm just using that from the example code. So let's look at the one other thing I haven't set up is I'm going to use pin 4, the left button on the Circuit Playground, as my input, so I declare that. Then my loop is actually pretty simple once I've got all the Bluetooth stuff set up. I'm testing out many things here. You probably won't have all of this in your own code, but I just wanted to show you an example of what it could do. So I'm saying if digital read 4 is true, right? So if that's high and Bluefruit.connected is true, right? So I only want to do this check or run these Bluetooth commands if the Bluetooth connection is established, right? So if both of those things are true, then sorry about that. Then run through these steps. So the first one is BLE HID, so my HID object, key press, and then I'm just typing in with single quotes the letter C, and then key release. And then I'm going to send the letter A release and the letter T release. Okay, so I could send multiple letters. If I only wanted to send one letter, per button press, I could delete all this, but I'm sending the whole word cat. And then at the same time, I'm going to say, okay, mouse move 1010. This is from the current mouse position. Okay, so from wherever the mouse is, move it 10 over and 10 down. Okay, so you'll see the mouse move like diagonally just a little bit. Mouse button press. We can do mouse button left, mouse button right, mouse button middle, etc. And then mouse button release. Okay, and then I'm going to delay my debounce from the beginning. So let's take a look and see if this works. I've actually already uploaded this to my device. It's running. I'm going to go over to my Bluetooth controls, turn my computer Bluetooth on, open my Bluetooth preferences. It's going to look around. Okay, so there's the circuit playground. I'm going to hit connect. So the first time you do this or work with this with any computer, you're going to have to make sure you connect it as a Bluetooth device. There's not a passcode or anything like that you need to do, and then it will remember the device until you remove or forget it. So future times turning it on and off, you won't have to deal with that. I'm going to move that out of the way, and then here, if I hit my button, I get the word cat. And you see the cursor moved, right? So if I click back up here, watch the mouse this time. As I click, you see the mouse move. That's not me moving the mouse, that's the 1010 there. I'll do it one more time. My hand's off the mouse and I click, and the mouse moves 10 pixels basically over and 10 pixels down. And then it does a click, which is why the line is moving there. So it's not the enter key doing that, it's that mouse click. If, for instance, I have the mouse up here and I press the button now, the cat will go where the cursor is and you'll see the mouse move and then click there. Okay? So that's pretty much it. The actual implementation of sending characters and mouse movements and stuff like that is very similar to doing it over USB. There's just a bit more setup that you need to do in Bluetooth and with this advertising to get the Bluetooth connection going. Once you have that set up, the rest is pretty easy. So hopefully this covers how you can use the Circuit Playground Bluefruit with a battery and how to send Bluetooth commands to a computer.